Welcome you all again. I think we can start the next session, and it will be uh, on Kafka, Kafka API without Kafka, and Arun and Anuj will be taking this session. Over to you, Arun and Anuj, for the next session.
Hello everyone, I'm Arun. I'm a senior consultant data engineer in ThoughtWorks. And Anuj, you can introduce yourself.
Yeah, hi. Sure. Hey, am I audible?
Yeah, yes.
Okay. Yeah, hi everyone. I'm Anuj. I've been working in ThoughtWorks as data engineer. So yeah, I think we can start with the slides. Can you share the screen?
Yes.
Thanks.
So the topic for today is Kafka API without Kafka. Before we start, we'll just take a quick poll on to know the audience better, how well familiar they are with this topic. So can we have the poll now?
Hello, Arun.
Hello?
You want me to initiate the poll, right?
Yeah, yes. Can you
Yeah,
start?
I'm doing it. Hello, people. I have launched one poll. Can you please answer? So, I'm ending the poll now. Yes. I hope you can see the results.
It's not visible to me.
So maybe I can share.
Yeah.
The question was, how familiar are you with the topic? So
Yeah.
we got 16% on I don't have much idea about Kafka. And we got 40 and 40% for I know Kafka, but don't have practical implementation experience. Then again, 40% for I have used Kafka a lot, but not aware of Kafka API without Kafka. And we got 4% on I have used both Kafka as well as Kafka API without Kafka.
Yeah, nice results to start off with. Yeah, so we see a lot of people are already familiar with Kafka, and yeah, they're curious to know more on this topic, Kafka API without Kafka. So let's get started. So our agenda for today is we'll just quickly do an introduction to the Kafka for people who are not aware of this, and what problems we have when we are using the native Kafka, and then we'll go with the Kafka API without Kafka, what exactly it is. And then we'll see some of the vendor offerings, some of the options that we have found in the slides, and then what are the merits, demerits, and end with the conclusion. So introduction to Kafka. So Kafka is an open source distributed event processing system. So it's an open source, and we can, whenever we need this event processing thing, so it's the first option that we take in consideration. You can ingest and process the real-time data, and it's widely used in the community for publishing, that's writing into the Kafka, and subscribing, that's reading that data back for the stream of events. We can even use it for storing. The stream of events can be used as storage, and for processing of these stream events. You can see this diagram over there, that's a Kafka logo. You can see the applications that are trying to write data to the Kafka, and then we can have those we call as producers, and then the same data can be read by different apps that are the consumers, and we can even store the data to the databases, And we have the stream processors as well, so that we can process that data real time using Kafka. So if you see the benefits of Kafka, it's highly scalable. Like it's in a distributed system, works in a cluster mode, and it can be easily scaled up as per the requirement. It's just a matter of adding new the brokers, and then your cluster will scale up. It's a streaming platform used to build real-time event-driven applications. So whenever you need an application that responds to events and not just the batch data, you can go for Kafka as a streaming platform. It can be used for a storage system as well. Like you can store the data into the Kafka, and then you can have multiple consumers that can consume the data at their own pace. So it's unlike publish, subscribe, MQs, wherein you publish data to a queue, and then once the consumer has seen the data, it's gone. But here the consumers can consume at their own pace, and producers and consumers act independently. So you can write your producers in a different, like a different team that produces to the Kafka, and consumers, and they don't have to be connected. They just need to know the topics where they want to produce it. So producer will be producing to that topics, and then consumers can read data from that. So they can work independently. And it's cost effective. So if you see, it's a real-time version of Hadoop. When we talk about Hadoop, it's mainly about the batch processing. You have a lot of big data over there, and you store it in a commodity hardwares. And when we see you want to bring in the real-time data, that's Kafka, what you call as a real-time version of Hadoop. And now let's quickly check what are all the problems we see with this Kafka. First thing is the cluster management. You'll have to manage a lot of things when you are having a Kafka cluster, the Kafka brokers, zookeepers, and other components involved. And then once we have the cluster set up, you have everything in place, then the broker configuration kicks in, wherein you have to set up your brokers, you need to scale, and you need to manage. So you can have a Kafka setup where everything is fine, but with a slight change in the broker configuration, you might not get the expected results. So you'll start complaining that it's not working well and it's not up to the scale. It's all about the broker configuration that you need to check. And maintenance, yeah, so replacements of the brokers on the failures, and then patches and upgrades. That's tedious task to do with Kafka alone. And then adjustment to fulfill requirements from different teams. So like I said, in Kafka, mainly the data is stored in form of topics and partitions. So there can be different teams that needs like different configuration for the topics. Few wants higher throughputs, and in some places we just need it for storing it. So and they need different retention. Someone wants the data to be there for a longer time, while for other teams, since there's a lot of data, you want it for a shorter period of time. So there are a lot of adjustments that you need to change. And you also need to plan the scaling of your cluster to support your load changes. And hardware selection is also one thing, though we say we can run Hadoop on commodity hardware, but then if you're really looking for high performance things, so you need to be very particular about your hardware selections for your Kafka brokers or Kafka servers, I would say. There's a dedicated admin required to monitor, because there are a lot of times the people who have worked with Kafka will know it will go down in some random reasons. So you need a dedicated admin that can monitor it to ensure you have a high available and durable Kafka setup available in your cluster. So these are few of the problems. If you have faced any other than this, you can just comment out in chat. These are few that we listed out. And then comes the Kafka API without Kafka. That's leveraging Kafka benefits without managing Kafka. It's in the tech radar SS string. So it's the same thing like what we have in Kafka, but without Kafka logo. So it's like taking all those advantages that we talked in the slide before. What are all the advantages that Kafka brings us to without the hassle of managing the Kafka? So there are various options available to solve it, either by offering a different architecture a totally different architecture from this Kafka, that broker topics partitioning. It's a total different architecture from Kafka. So it can be compatibility with the Kafka producer and consumer APIs, wherein it's the same Kafka producer and consumers that you were using earlier with the Kafka, and then you migrate to this Kafka API without Kafka. You reuse your code, but then you're not managing the Kafka, underlying Kafka there. Or providing a completely managed service wherein you don't even have to think on, you don't have to provision also. So it's completely managed service. So you just know you want a real-time processing, and you just can take one of that options for your experiments or your real-time applications to see if that is if real-time processing is what you're looking for in your use case. And then we have the vendor offerings, few of the options that are available for this Kafka API without Kafka. We'll be discussing the few of them. So first one from the cloud, AWS is AWS MSK, that's managed streaming for Apache Kafka. So it's the managed version of Kafka. So, but you still have to instantiate the Kafka instances. That will be the EC2 instances. So if someone is already working on AWS, so they'll be aware of this thing. So you just have to start up your instances, but then the Kafka thing will be managed by AWS. So it includes all the benefits of Kafka. As you see, underlying it's still the Kafka. So whatever you get from the normal Kafka, you get it in MSK as well. And it's fully compatible with Kafka APIs. So if you have your code that your producers and consumers running in your own on-premises, and you want to shift it to cloud, so you can just bring in your own code without any much changes, just the configurations of your broker addresses and all those things. You can still use your own code that's fully compatible with the Kafka APIs. And here you need not to worry about the Kafka instances going down or all the issues with the Zookeeper that normally we see when we are managing Kafka on our own. So here the AWS takes care of managing that Kafka instances. And yeah, so that's about the MSK. Like I said, the Kafka libraries are still supported by the producer and consumers. So like creating topic, listing topics, all those Kafka operations still stay the same. So if you want to migrate to cloud, and with the minimal friction, so you don't want to change anything, you just want to migrate to cloud, you are on-premises solution with Kafka, this is the easiest track to follow. And it's also good for the app owners who are considered about the vendor lock-in things. So they don't want to move to such a solution that's vendor locked in, and they should be able to move back to another cloud later if they want to. So MSK is the option for such a use case. And then we have Azure Event Hubs for Kafka. That's something similar coming up from another major cloud vendor, the Microsoft Azure. So if you see, this is a fully managed service. In the AWS MSK, we still had to provision some the instances, the EC2 instances or Kafka servers, but this is a fully managed. So you don't have to think about the server, what disks you want to be using, what networks, nothing. So there is no broker at all to configure or to consider. So it's completely managed by Azure. And it provides seamless integration with Azure data services. So those who are already aware of the Azure Event Hubs, so this is Azure Event Hubs for Kafka. So you get it, your Azure Event Hubs, your all integration with the Azure data services, like your Azure Stream Analytics or Azure Functions. So everything that you get in a normal Azure Event Hubs, you can get it with Kafka as well using this wrapper. And it's easily scalable, like in normal cloud platform. So if in case of Azure Event Hubs, you can specify your throughput units, like how many processing units you want to purchase. So you can straight away say, okay, I want this many throughput units, and you'll be getting it. And there is also an auto inflate feature that automatically scales up your cluster with the load. And it's compatible with Kafka API and consumer groups. So it's actually, if you think of Azure Events for Kafka, it's just like it provides you an endpoint that is compatible with Kafka producers and consumers. And it's for the Kafka Server 1.0 and above. So you just get a URL and underlying, you don't have to think it's, you can assume it's a Kafka. So you just got the URL of Kafka. You can start using your own consumer APIs, the producers and consumers, also the consumer groups, all those things. And then Azure will manage things for you. And also it enables the real-time micro batch loading through the capture feature. Most of the times when we talk about real-time processing or real-time storing, the processing is something you take in the real-time data and then you process it. And that's more on a ping pong situation that we'll see in the next Red Panda solves. But then there are other use cases wherein you just want to ingest the data into your in your data layer, on your data lake. So for such a case, you can write your own code for ingesting that real time, but with the capture feature, you can just specify your micro batch timing, like you can set up a window time or a size based window, and then you can specify where you want to store it to, like as your blob storage or as your data lake storage, wherever you want to. So with this capture feature, it will seamlessly read that input feed, the real-time data, and it'll just ingest it also to the data lake. That's it for the Azure Event Hubs. Then Red Panda. Anuj, can you take it from there?
Yeah, sure. So I hope I'm audible.
Yeah. You want to share or continue sharing?
Yeah, I'll have some trouble in the like sharing the screen. I
Okay.
have some network issues there.
Yeah, then okay, I'll share.
Yeah, so going ahead with Red Panda. So basically, it's a modern streaming platform that's gaining popularity nowadays.
Anuj, your voice too low.
So
Can
Arun, like, can you help me? A bit?
Anuj, we can't hear you.
Anuj, you're on mute in case you're speaking.
Hey, Arun, just click on the screen once. Okay. So the basic feature that Panda provides us, why it is listed here, is that it is actually Kafka API and ecosystem compatible. So when we say like it's compatible, that means like we can have like producers and consumers written in our app that can basically read and write to Red Panda without changing in code.
Sorry to interrupt you. Is it only me hearing very low volume? Okay, so we have the chat on chats also, like there are a lot of Arun, can
Yeah,
you
now can you hear me?
no, it's
Hello.
very low.
Still very low. Okay.
You're not proper audible. So I guess you can put your
Arun,
mic
can you,
near to your.
if you don't mind, can you take it? If
Yeah.
there's some issue with Anu's audio.
Yeah, no issues. Then I can take it. Unless you can take it on Q&A, yes. So as I was mentioning earlier, so it's Kafka API compatible, ecosystem compatible. So you can bring in your own the Kafka producers and Kafka consumers and to the Red Panda. And another one is the rolling upgrades. We see the problems that we have in Kafka is the rolling upgrades part. You have to tackle it with there are a lot of things that involves when you upgrade the Kafka clusters, and Red Panda provides rolling upgrades that solves that problem. And there is no partition limit. So native Kafka has a limit of 2 lakh partitions. That's actually a very high number, but yeah, when you are working on applications that expects more than this throughput, then you can go with Red Panda because that has native Kafka has limit on the partitions. Then there is zero data loss as they claim. In native Kafka, you might experience such a scenario when performance is degraded because there is interdependency between various components and also how Kafka implements the disk level storage. So there can be scenarios like most of you who have worked with Kafka would have experienced a data loss unless you have the acknowledgement set to high. And Zookeeper can be eliminated. So in Red Panda, you have an option to eliminate Zookeeper. And it comes as a singular binary that you can install and just start using it. Whereas in Kafka, you have to set up Zookeeper, broker, and all those things. That thing is easy with Red Panda. And there is a native Prometheus port. So the metrics of the platform will be exported. So you can build your monitoring graphs, Grafana or Kibana, so you can have a better look how your cluster is performing at any time. And there is an okay. So and there is inline WASM transform that's mainly WebAssembly, how JavaScript as WebAssembly works. So it just ships the static content along with the code. So in here also we can make use of this WASM transforms. So it's basically the problem that I said, right? The ping pong data problem. Most of the real-time processing, we just read from one of the topic, process something, and then send it to the next topic. And then you read it, you reprocess, send it to the next topic. So there's a lot of data ping pong happening. But with this WASM transforms, you can actually give it a piece of code like a normal transformer, be it a WASM or JavaScript code, that you can say, okay, whenever I see such an event, you want to transform this way. It can be like adding new fields to it, enriching the data, or just shifting, like handling nulls or stuff like that we mostly do in the real-time processing. So you can ship that along with the code, and whenever you have a data, it'll just inline transform those events. And another part is the Kafka Transactions API is not yet supported. So the transaction API mainly, so if you have an application that works on the, say, for example, the web logs or the click logs. So in such a case, you won't mind skipping an event or when you duplicately transform an event twice. But for the cases like for the banking solutions, like if you're handling transactions like credit card transactions, such things you cannot avoid to be done in the transactions. So in that case, Red Panda might not be a good choice because they still don't have a transaction API supported, but they are in progress to implement that as well. And the next one is Kafka on Pulsar. So if you are aware of the Pulsar framework, so it's also a cloud native distributed messaging and streaming platform that was built initially by Yahoo. So this Kafka on Pulsar, like if you have Pulsar already in your tech stack, and then you can bring in the use of Kafka on top of the Pulsar thing. So it's just a protocol over the Pulsar to handle the Kafka APIs. So it's a multi-layer design. Like I said, in Pulsar, you have a concept of a protocol handler where you can design your own protocol handler to connect with other data options, and this Kafka is another protocol handler for this Pulsar. Underlying it's still the Pulsar architecture that works. And like Red Panda, there's unlimited partition scalability. Like earlier we see, right, there's a limit on Kafka partitions, but just like Red Panda, here also we don't have any limit on the partition scalability. And it's partition rebalance free architecture. So if you have worked on Kafka, you would have seen that problem of rebalancing. So you get your data skewed in some of the partitions and you have to do rebalancing manually sometimes. But here, as in the native Pulsar architecture, you have the load balancer available to you. So it manages your load. So you don't have to think more on the rebalancing part of Kafka. And it ensures the instant scalability and higher availability. So it follows the horizontal scaling. So if you want to increase the capacity, you can just add on more bookies that they call in Pulsar architecture, like brokers we say in Kafka. So you can add on more bookies and it will increase your data capacity, so it can scale very well, and it can also handle those bookies, right? They handle ledgers. There are two disks. They use multiple disks actually. One to maintain a journal, and another one for the journal storage, and that enables them for a concurrent read write things, and it mixing Kafka on Pulsar is highly available solution. And the cluster application provided out of the box so those who have worked on Pulsar would have aware of this part. So Pulsar has this global replicators, and then replication gets you get it out of the box. And for all those things, you can even use it as an open source long-term storage. So you can bring in. So if your use case was more about using Kafka as a storage, you can still use it on the Kafka on Pulsar for the long-term storage purpose. So that was few of the options that we have. So let's just quickly go through the merits, what we get with this Kafka API without Kafka. So the main thing that we noticed in all the options that there are no code changes needed for different experiments. So you can, if you have something to experiment on, you don't have to change a lot of code. You can just pick up this Kafka API without Kafka solution, and you can experiment your use case to see if it works well. And also, if you see each solution that we talked about has its own unique advantages. So some of them were like, no need to worry about Zookeeper, like in managed services, you don't have to think about on managing the Zookeeper things. And it can be, some of them are fully managed services or fully managed Kafka, like in MSK. So easy scalability in partitions, most of them provide this option, and there is no limit on creating more partitions, so you can have more throughput for your applications, the real-time applications. And when you talk about demerits of Kafka API without Kafka, the first thing would be it's not widely used. Like we saw it in the poll, right? There are very less people who are using it right now, so it's not a widely used concept. Kafka still claims to have lowest latency. So if you know Kafka very well, if you're very well versed with the broker configurations and you can make it working fine, then it still claims to have a lowest latency. It's just that we need to tune it based on the loads, and that's little tricky. And then we get into the problems with Kafka sometimes. And Kafka comes with more community support. It's been there for a while. And so there are a lot of big companies that already use Kafka, and there's also a lot of community support available. And less control over granular configurations. Like if you want to configure something like, for instance, one example would be if you want to increase your message size, most of the options that you see, right, in Azure Event Hubs or something like that, there is a limit on the what maximum message you want to send in. And that's a good thing to have in place, because we are building a real-time applications, that's event-driven applications, and we want our events to be smaller size. But for a special case, like I had in past with Kafka, wherein you have to transfer a real big workloads, like 5 MBs or more. So such a case, if you have Kafka, it's very easy to change those configurations. And then you can also tweak your in-flight experience, like what latency you want to tune in and what throughputs. Everything is in your own hand when you are working with Kafka, but those things are not much available when you are working with Kafka API without Kafka. And yes, since some of them are managed services, so there will be an extra cost incurred when we're using the Kafka APIs without Kafka. And yes, so they're not supporting the stream processing API yet for Kafka, and also a few of them do not support the transaction API as well. So that's also a call you want to take when you're moving to Kafka API without Kafka. So then moving to the conclusion, Kafka API without Kafka. So before we go into the conclusion, I just want to take another poll to see an audience what they feel is a better option. So can we start the poll?
Yeah, I already started.
Okay.
Yeah, I can end the poll now. I got 64% response. So
61. So I
no,
think
I total 61 participants. So can you see the results, Arun?
no, I don't know why, but
Okay.
I'm not seeing the polls
So
result.
I can share the results. So the question was like, what according to you is better opinion? So we got 99% for Kafka and Kafka API without Kafka. And we got 82% for it depends on use case. Both are good in their own ways.
Okay, yes, yeah, that's a good choice. So let's just conclude here as well. So who won? So there are a lot of variants available in the community for different use cases, and accordingly, a choice can be made, like what we got from our poll results. So when we want to choose Kafka, so choose Kafka if you need more control over Kafka cluster and want to configure till the very granular customization, that few of the cases that I shared earlier. And you're already working on on-premise systems with Zookeeper, Hadoop cluster, etc., are already managed. So most of the cases where you're running an on-prem Hadoop, I know most of are shifting to cloud, but there are in banking some clients that are very particular about few applications on the data security. Like one of the project that I had in past, so their concern was regarding the customer security. So a particular piece of code was already on-prem solution. So in such a case where you already have an on-prem Hadoop cluster setting up, so you anyway have to manage Zookeeper, you anyway have to need an admin. For such a cases, it's okay to keep Kafka over there, because that won't be a much trouble to you, because you're already managing the ecosystem, the part of ecosystems. And another case, choose Kafka API without Kafka if you're working on the cloud solutions, if you're working with a diverse set of tech stacks with common libraries, and to avoid manual efforts in setting up Kafka clusters. So that's also another case. So I've seen sometimes when we think about real-time applications, we bring in Kafka thing. And I had experience in past wherein we were on Azure cloud. So all our applications were the .NET driven applications, but then we wanted to have the real-time processing. So we bring in Kafka, and to manage that Kafka, we had to set up another dedicated admin teams for Kafka, because it was getting a little difficult to manage the Kafka cluster itself. So we were on Confluent Kafka at that time. So for such a case wherein your tech stack is totally different, so you're not managing those components, it's good to go with the cloud options or the Kafka API without Kafka, so that you concentrate more on the logic, the processing, and you have to work more on setting up those clusters. So Kafka API without Kafka would be an option, good option there. So yeah, like it said, it depends on the use case, and accordingly a choice can be made. That's it for the conclusion. There are a few of the references that you can go through if you want to study more on any of these options that we talked about today. And that will be shared with you. Those links will be shared with all the participants later. And questions. So quickly check the Q&A if there are anything.
Yeah, I think there are a few questions. Maybe you can take it live.
Yeah. So how are these Kafka APIs without Kafka offerings different from Confluent Kafka offering? Yeah. So in the, shall I answer it here, or I'll just answer it later? Right?
You can answer it live.
Yeah. So the Confluent Kafka offering is, yeah, it gives you a lot of other benefits other than Kafka, but then you still have to manage your Kafka cluster there. You still have to create your brokers, your zookeepers, and you need to monitor all those things. A lot of things you have to still manage on your own. But when you talk about a totally managed service, or you're already in a setup, like suppose you're already in Pulsar, you're already using Apache Pulsar in your project, and you want to shift to Kafka because some of the upstreams applications are Kafka producers. So for those cases, it makes more sense to switch to Pulsar. And if managing Kafka is one of the problem that you see, Confident Kafka, you still have to manage things on your own, and then you can go for completely managed services. Say maybe Azure Event Hubs, wherein you just get a URL and then you start working on that. Or if you really want real-time stream processing, there are other options as well that will solve the problem of real-time processing.
Yeah, Arun. So like I would like to add some points to it. Like, so most of the problems that we stated in this slides that are still there, like there's a limitation on number of partitions in Kafka, right? So that will not be changed. And other than that, like there's still something in works which will like help you in like geo replication of Kafka cluster, but still not like completely supported yet through Mirror Maker and all. So these are like some of the examples which will still be like be a hassle for you according to your use cases. So if you like have a specific use case, so you can like go through these various options and choose like whichever the one like whichever is better for you.
Thank you, Anuj. And there's one more from Nitin Singh, and it's just a link. So Nitin, can you say what exactly your question is?
Nitin, are you there? I don't see Nitin in the call. Oh, Nitin is there. Nitin,
Okay.
you want to talk about a question like Arun is asking?
So I want to ask one thing regarding the Azure Event Hub and the Kafka integration. So whether Event Hub work with Kafka internally or they just use their API for sending the messages or accepting the messages.
So you're talking about the link that you pasted, like Kafka Connect.
Yeah.
So the, like Kafka provides a API like Kafka Connect to connect with like different storages, right? So that is there, but you still need a lot of extra code to support that, right? You have to use the Kafka Connect. But what we are providing here, like Azure Event Hub for Kafka, you don't have to change your application one bit. The Kafka consumers and producers that you've written in your like application code, so that you don't have to change. You just have to like use that Azure Event Hub for Kafka, and then you like are good to go.
So there is no change in the code, right?
Yeah. If you're using like this Azure Event Hub for Kafka.
Okay.
And
Thank you.
the terminology they use is also somewhat similar. So in Event Hub, what we have Kafka topic in general is you say Event Hub, producers, consumers stays the same, and then Kafka cluster, they call it as namespace. Yeah. So
Yeah, similarly like a consumer, so consumer groups is the same concept. So it's really like almost on the same architecture.
Okay. Thank you.
So
we have another question.
yeah, we have one more question in Q&A. This is like, for new projects, is it worth going to Kafka, I think Kafka API without Kafka, or just use a cloud service like, I don't,
Kinesis
yeah,
or Event
Kinesis
Hub.
or even Hub, yeah.
Yeah, so I would say it depends on the project actually. So if you are doing a POC kind of thing where you want to work more on to see if your use case is really a real-time processing thing. So in that case, I would say just try a managed thing. Like Kinesis is a good option over there. My preference also for the Kinesis actually, because I worked more on that. So it's very easy. You just bring in real-time streaming as a concept for your use case. If you think it's good, then you can shift to pure Kafka. If you see its pricing is not thing, or you really want to tune on more parameters, then you can go with that. Or if you think for your load it's working fine, then it's okay.
So I would like to add some more points again. So basically, one thing is that with Kafka API, without Kafka, you get a lot of options. Like there are like managed services as well, like clouds. We already told like Azure and AWS is still in line. You can use those with Kafka API without Kafka. Next thing is like for such use case, like where your developers are actually more proficient in Kafka. So you can write the code, which is in Kafka API, Kafka producers and consumers, and later on you can choose uh, whatever you want to. So it won't bother the developers and it won't hassle your code completion. So that would be one of the use cases. But if you if you are really good confident that you want to start with some specific service according to users, it won't matter much. You
Anuj, I
can
guess like volume also plays a good role there, right? Because all these platform as services normally offer you pay as you go, but if you go on to spin up your own Kafka setup, you'll have to pay for the machine all the time you're running it, right? So you won't be paying just for the messages. That also adds on if you start
yeah,
considering
true.
factors. Yeah.
Yeah, true. Like if you're going for managed services, it's always like extra cost. It will always be extra cost. So yeah, right. Okay.
Okay, so I don't see any hand raise or any Q&A question in Q&A section. So thank you for your time. I think. Oh, so Nitin has raised one hand, so maybe I will allow him.
So I have one question regarding it, regarding Kafka. I have worked in the past using Kafka on microservice-based architecture. So there is one use case in which we have multiple nodes, and each nodes communicate with over a topic with with another node. So there was a requirement in which we have to let manage the message, or you can say we have to save a message if any of the node communicating node goes down. So what will be the best approach for handling this kind of situation?
I didn't quite get your question. I'm sorry. Can you repeat again?
So there was a use case we are having a microservice based architecture in which each node, multiple nodes we are having, and each node having the part of a component of the application, and each communicate with another component of the application using Kafka over a topic, using through a topic. So there was a use case in which let's say if any of the component gets down or nodes get down over which it is deployed, so to log such kind of thing or to save a message from getting disappeared, what is the best approach, I want to uh, ask.
Yeah, so I think it depends more on your configuration. Like, what I understood from your question is you have few producers that communicate to another, like consumers in your case. So you have
Yeah, yeah.
producers producing to the Kafka topic, and then you have consumers that are reading through the same topic, and you have sometimes those producers going down.
So
Consumer get down when
Consumers.
who.
So are you using consumer groups when you're consuming from Kafka?
Not it was a from one of my past project. They are not using that consumer group functionality.
Okay, I think
So then let's say there is a producer who generates an order. So we have three component: one for printing invoices, one for processing the order. So let's say the invoice generating component gets down.
hmm.
So this kind of situation we are.
Yeah, I think consumer groups can solve your case because they keep a track of the offsets. So the producers can still produce to the thing, and if you are using a consumer group over there, your offset, that last read message will still be there. And when you monitor your health of your producer, if you feel the consumers are down, and if you restart those, then consumer group will ensure you will read exactly where it was written last, using that, committing only those partitions that that I've seen earlier.
Yes, like for each application, use a different consumer group.
Yeah.
And a specific consumer group, like so that you can pick up from where you like read like last read message.
Okay.
And
Thank
another thing you can do is like you can switch off the auto commits. So like whenever you're reading from Kafka, so basically like there can be multiple edge cases, but in the general scenario, you should switch off the auto commit, so that when you actually consume the message, it will not reflect that you have read the message. Like after you completely processed it, then you commit that message that I have read this message. So there's also like a auto commit functionality that you should turn off.
Okay. Thank you.